It's power. One of the main things that you've got to figure out for your spacecraft. In all of these different videos we've been showing you so far, what we've basically been going down the path of is time, because time is very important. The time that your mission must survive, and measure things. The reason why we need time is it is a part of how you determine how much batteries, how much mass you need for batteries, right? So what we've done with you so far is we told you guys back in the instrument section of this project that you needed to go find these instruments or support equipment, right? So the instruments are the mass spectrometers or the pressure transducers or the thermocouples or whatever you're doing. Then the support equipment, you could have antenna, you could have accelerometers, you could have processors, you could do all kinds of things, you know? All those things take power. So anything that takes power, we've been telling you to go find that power, right? And power, if you remember, we've been probably telling you every time we've been there, power is IV, right? So amps, current, times voltage, right? So amps and volts is what we're really after. And that's how you get watts, because the watts are the most important part of this, okay? So once you get those, and you've got these listed, you already had them in your instrument requirements table. So once you know these powers, that's the big deal, okay? So we got the powers, check, we're done. Operating time in hours is the next thing we need to understand. By doing these analysis that we've been showing you in these little videos, hopefully you figured out how long your mission lasts, okay? That's the important part, because basically, however long your mission lasts is how long you're going to measure stuff, right? So that's probably the best case to use. So once you know that operating time, you can then plug that in as well in a table, okay? Done. Check on that one. So now what we got to do is figure out the total power we need. Batteries are not sized on watts. They are sized on watt hours. So how much power do you need for a given length of time is really what you're after. So all you have to do, if you know the power and you know the operating time, you multiply those together. This is what you did in 3rd grade, okay? Because I know my daughter's in 3rd grade. So this is what you've done. So multiply that together. Ta-da! That's how much total power instrument 1 takes. AB, right? Instrument 2, CD. Instrument 3, EF. We get this, right? We understand what we're doing here. And it's like decision analysis. It's some of the products. So the total power that we need to use is basically AB plus CD plus EF plus whatever, right? That is the total power that your payload is going to consume that you need, okay? Now we can figure out how much battery we need, because we know the mass of a battery is the total power that your payload needs divided by 400 watt-hours per kilogram. We know spacecraft batteries, these are primary batteries, which means they discharge and it's over, which is exactly what your mission is. Your mission is not going to sit around and worry about the planet for the next 10 years. Not going to happen. You're going to die. And so what you need to do is divide by 400. So whatever power you have divided by 400 gives you the amount of battery that you need. Okay? Very simple. The hardest part of this entire thing is finding the power of these things. Okay? So if you've got it in volts, we'll help you. If you've got it in amps, we'll also help you. We'll come up with a way to figure out what it should be in watts. This operating time, I'm not going to stress this enough. This is your calculation of how long you need to last, okay? And it should be based on engineering analysis. It shouldn't be, well, I think it's going to be 5 seconds. No, it should be based on engineering analysis of when does your mission begin and when does it end. You should be able to calculate that by now. With that known, divide by 400, sum them up, divide by 400, you got the battery mass, okay? And you have made a major big deal to most people in planetary science, because trying to figure out how much power you need is a big deal, and you just did a check mark of a big one, and so you'll impress the board a lot. So hopefully this will help you out in what you're doing. As always, you know how to contact me and Matt, and we'll talk to you later. Bye.